Hello everyone. So as we watched in the previous video, if you have not watched that video, so there would be a link in the description and there would be a icon over there, suggested video icon. That in the previous video we discussed about the area under curve, means how do we calculate area under curve using integration. So in that video we basically discussed about how to visualize, means why we are using integration to find out the area under curve. Now we'll apply the same in this, means how to solve questions on the basis of that, how to apply integration properties and rules. So let's start with this. Consider the area bounded by the curve y equals to x square, and the x-axis and the line x equals to 2 and x equals to 5. So basically we are calculating this area, and if I shade this part, so let's suppose, so this is the area we are supposed to calculate, and we know this is not a complete, or this is not a polygonal shape, so there is a curved path over here. So as what we did in this part, so let's suppose if I am dividing this into small rectangles, okay, and the length of this rectangle is, let's suppose, dx or del x. It's very small, and on the basis of that I'll use this concept what we have discussed in previous video to apply and find out. So basically area under curve is you divide the whole portion into small and you sum up the area. So it's over here that the area A of the region can be approximated by a series of rectangular strips of thickness del x, and which is del x is basically a small increase in x. So if there is a small increase in x, how your function is changing. So that's the idea. So this approximated change for A, we can add up the sum of all the small areas of that rectangle, and if this del x is very small, means if this del x is very small, then we can write down the area using the formula of integration in the given limits. Clear? So let's continue with this idea and let's apply this generally. So how do we solve? Let's suppose a function is given y is equals to fx, and let's suppose your y is greater than equals to 0, means it's above the horizontal x-axis, okay, and we are supposed to find out the area bounded by x-axis, x equals to a and x equals to b. So we can use the integration. So whatever is function, we'll write down the function in terms of x and we'll integrate in the given limits. Okay, so let's do some questions on the same. So the area of the shaded region, and the curve is given to us over here, that is y is equals to 3x square, and we are supposed to find out this from the region 4 to 6. Okay, so if I integrate this area from 4 to 6, integration of 3, since 3 is a constant over here, so if I take this 3 outside, what is the integration of x to the power 2, that is x square? Integration would be, as we know, x to the power n, integration is x to the power n plus 1 divided by n plus 1. Okay, so using that concept, x square integration would be x cube divided by 3, and we use the square brackets to write down the limits. Upper limit, so the 6 is my upper limit, this is my lower limit. So always first we put upper limit, then subtract the lower limit. So if you put 6 over here, this is what you will get, because you can simplify over here, this 3 and 3 gets cancelled out. So x cube means 6 cube is 216, minus 4 cube, which is 64, simplifies, give your answer as 152 unit square. Since we are working with area, and unit of area is always square unit, so whatever is the unit, so unit would be unit square. Okay, let's do one more question over here. Okay, yeah, this is good. Same logic, where now again the area we need to calculate is between x-axis and the 2 points 0 and 6. So if I integrate this part, so what would be integration of, I know integration we can distribute over addition and subtraction, so I can individually integrate this term and put up the values, limits. So what would be integration of x square? So integration of x square would be x cube by 3 minus 6 is constant. If I am keeping 6 outside, what is the integration of x? So integration of x would be x square by 2. Limits 0 to 6. Now if I can simplify this part over here, this is 1, this is 3. Now let's substitute rewrite this. So this would be x cubed by 3 minus 3x square. Now if we substitute the limit, first is your upper limit. So if you put upper limit, so this is 216 by 3 minus this is 36. 6 square is 36. 36 into 3 is 108. Now we can simplify this part. 216 divided by 3 minus 180. So you can take LCM and you can write down answer. So over here, if you simplify this part, so your answer would be negative 36. Over here, your answer would be negative 36 square units. But since we are working with area, so final step which I am going to write down is, I'll write down area is equals to 36 square units. I hope this is clear. Any doubt? Okay, so when we are writing this final step, our area would be 36 square units. Clear? Okay, now let's do this question. First you try it out, because we will not answer our area in negative. So answer of area, because area cannot be negative, answer of area would be positive. So area at the end will write down 36 square units. Now at times over here that the student get confused over here, since we are supposed to find out the area between 0 to 6 in total. But if you observe carefully, this is above x-axis and this is below x-axis. Now the part which is above x-axis is going to be positive and the part which is below x-axis is going to be negative. Now what happens is, either you can divide this into two parts, means I can calculate my area between 0 to 2 and then 2 to 6, then positive part of that area I can sum up and I can tell this is the total required area. So if I calculate this part, yellow part, so function is this, so I just multiplied this function, so you get this part over here. Now integration of x cube would be x to the power 4, same formula, x to the power n, integration is x to the power n plus 1 divided by n plus 1. So now limits are 0 to 2. First you put up the limit s2, so you'll get 2 to the power 4 by 4 minus 8 2 cube by 3 plus 12 square. And similarly if you put 0, so this is ultimately is going to be 0 because everything over here is 0. Now if you simplify this part, you'll get this as this is 6 2 by 3, or which is equivalent to, if you write down, that is 20 by 3 units square. Okay, now the red area. So red area lies between 2 to 6, this portion to this portion, and function is same. So I'll integrate the same function from 2 to 6. Since this part we have already done, so we'll directly integrate, because integration will lead us to the same, because we are using the same function, only limits is going to change. So if we do, integration is same, 2 and 6. So first is upper limit over here, then lower limit. Always use brackets and negative sign, because at times student make mistake over here with sign. Okay, now once you simplify this, you'll get this as negative 42 2 by 3, which, but since we are working with area, we need to write down this in positive form. Okay, now the question was, what is the total shaded area? Total shaded area of the region. So total shaded area would be yellow plus red. If you sum up, then you'll get the total shaded area is 49 1 by 3 units square. This is 6 2 by 3, which is 20 by 3, 42 2 by 3, which is 128 by 3. If you add up and if you simplify this, you will get 49 by 3. There is no problem writing your answer in decimal, but whenever we write down in answers in decimal, make sure you write down in 3 significant figures until unless it's specified. Okay, now there must be a question, sir, why we have not integrated this from 2 to 6 directly? why we did this 0 to 2 and 2 to 6? Because the reason is, if you integrate this as 0 to 6 directly, you will get negative 36 square units. Now what's the problem? We did 0 to 2 and 2 to 6. We are getting something around 49 1 by 3. But over here I am getting 36. So what's the problem? Because when you integrate this entire region together, so what happens? Your positive area and negative area simplifies and give you a simplified answer. But since we want total area, so we divide. So always make this a point whenever your graph is crossing x-axis. If the part of the graph is below x-axis, so separately calculate that area, then consider the positive of that, because since we are working with the area, it has to be positive. Take positive of that, then sum up all the areas. That will give you the correct answer. This is not the right way. This is not the right way, that if you integrate 0 to 6 directly, you will not get. Because if you see the graph, some part was above x-axis, some part was below x-axis. Let's suppose if this is 6, this is 12, negative. So final answer you will get as negative 6, because it will simplify it. But if you do it separately, your final answer would be 6 plus 12, which is 18. So are you getting my point? Whenever your graph is below x-axis, calculate the area separately and take the modulus of that, because since we are working only in area and area has to be positive, then sum up the areas. Okay. So till now we have seen that we have calculated the area between the curves and lines which were bounded by x-axis. What happens if the curve is bounded by y-axis? Means let's suppose if this area. So the idea remains same, logic remains same. This time if you are making rectangles, this rectangles you will be making on which axis? Y-axis. So instead of dx, this would be dy. So if your small portion, width of your rectangle is dy, then your function has to be in y. So that's the thing. Now the orientation of function would change. In previous question, y was your subject and function was in terms of x. Now x would be your subject and function would be in terms of y. Now same idea, function in terms of y and dy. Okay, so let's quickly do a question on this. Simple, we are supposed to calculate this area between 0 to 4. This is my function. See, if you look at this function, this is basically fy, which is given to me y 4 minus y, and I am supposed to calculate area between 0 to 4. So I can write down area integration 0 to 4 y 4 minus y dy. Yes, now if I simplify this, 0 to 4, 4 into y is 4y minus y square, and this is given. Now if I integrate this, 4 y square by 2 minus y cube by 3, and your limits are 0 to 4. So always we first put up our upper limit, then we put up our lower limit, and this can be simplified over here. This is 1, this is 2. So basically this would be 2y square over here. So if I write down this as 4, 4 square is 16, 16 into 2 is 32, minus over here 4, which is 64 by 3. So this is my upper limit, minus lower limit, since it's 0, so 0 into something is 0, minus 0, it remains 0. Now you can make this as, I can write down this as 96 by 3 minus 64 by 3, because this is the equivalent fraction of this. We'll get this part. Now it becomes very easy for me to write down 96 minus 64 by 3, and if you subtract 96 minus 64, you will get 32 by 3 square units, or you can write down unit square. Okay, I hope the idea is clear now. How do we calculate area under the curve? Okay, so in next video we will discuss about how to calculate area between two curves, means area bounded between two curves. So I think this part is clear. So thank you for watching this video. If you have watched till end, if you liked the video, please like, share and subscribe, support us. And in next video we'll discuss about how to calculate area between two curves or area between a curve and a line. Thank you once again. Thank you.